In this module, we are going to look at proofs associated with universal or existential quantification. So one of the important rules that I want to uh, remind you of this is from module that we considered earlier, uh, which was how to add or remove universal or existential quantification. So let's look at an example. This is an argument from Socrates going back ages. So the claim goes, all men are mortal. Socrates is a man, therefore Socrates is mortal. Now what we are going to do is, first of all, we are going to convert this into formula, and then we are going to see how we can identify premises, conclusion, and how we can go about proving it. So we have h of x is a man, m of x is mortal, s is Socrates. So the statements we have are, for all x, if x is a man, x is mortal, Socrates is a man, and our conclusion we want to prove is Socrates is mortal. Now in this case, this whole thing is our premise. This is our conclusion. This premise consists of two parts. This is part 1, this is part 2. Okay, so let's look at the proof. We first start with the premise. For all x, h of x implies m of x. Now, the next thing that we are going to do is we are going to instantiate this with some x. In particular, we are going to set x is equal to s. This is our rule universal specification because the property is true for all x. So in particular, it is true for one of them, namely Socrates. Now the rest of it is straightforward. I have h of s. I apply modus ponens. Now that will prove what we want to do. Let's look at one more example. Now in this example, unlike the previous one where we were saying that Socrates is a man, here we are saying there exists some x, there exists a man. And our goal is to show that there exists somebody who is mortal. Again, we are going to start, there exists x, h of x. That's our premise. Now what we're going to do is we're going to apply existential specification. So here when we apply existential specification, we will get h of y for some y. This is the important part. So I don't know what that y is. I just know that there is some y for which this property is true. Let's continue. Let's use the other premise. For all x, h of x implies m of x. Now, I'm going to instantiate in this, I'm going to set x to be equal to y. Now remember, x is a variable here y is some specific human being. And I can instantiate that will give me h of y implies m of y. Now I can apply modus ponens to get m of y. Now what do I have here? I have proved that the property the property m is satisfied by some y. I don't know what that y is, but it is satisfied by some y. Now what I can do with this is I can apply the existential generalization to say there exists some x such that the property m of x is true. Once again, what I wanted you to do with this proof is see if you understand what's going on. If you are not clear on some step, identify what that step is, and then we can discuss this in PHR, in class, etc. Once again, we are at the check before you go ahead slide. I want you to see how the existential or universal instantiation and generalization was used in previous proofs.